Hey everyone, David Twyble here. Last week I started a series called Aerodynamics 101. In this second video, I want to talk about the chord line. Last week we talked about the definition of an airfoil and how the chord line runs from the leading edge to the trailing edge of an airfoil, and that it is a straight line. And that's a pretty straightforward, kind of boring definition. What's the benefit of this straight line? Well, there's two reasons that we use airfoils, or that we study airfoils in aerodynamics. And the first one is to provide force to lift the airplane, to provide lift. And the second is to control the airplane, or to change the direction that the airplane is going. And so the chord line becomes very important in that definition, because the chord line can actually change. And we're going to show that here with this model airfoil. And we can see here we have the leading edge and the trailing edge. And I've also put in what we're going to call for now just a control surface. And that's a hinged part of the backside of this airfoil. And so if we move the trailing edge down around the hinge point, we see that the chord line changes its angle. It goes from level to a down angle. And if we lift the trailing edge, we see that the opposite happens. And so we can see that the chord line is not always static. It is not always just leading edge to trailing edge through the middle, or the supposed middle of this body. But if we actually move the trailing edge or the leading edge, we can move that chord line. And that's important as we study more into lift and control, because we need to be able to change those forces that allow us to lift the airplane into the air and to control it. And we're going to do that by shifting the chord line primarily. So now you know that the chord line does not necessarily run through the body of the airfoil, but it can actually run outside of the body, and that's okay. So next week we'll look at another aspect of airfoil definitions, the camber line. Until then, fly safe.